Hi, I'm Brian with Pioneer Builders. I'm a second-generation builder, and this channel is devoted to all things design, construction, operations, and maintenance. But in this video, we're going to talk to you about repairs. Even as a new construction builder, sometimes things go wrong, and we have to go back and fix them. In this case, we thought we did everything right, but as it turns out, we didn't. Or at least we did to the best of our ability. There was just some knowledge that we were lacking. So first I want to explain to you the history about this particular situation, and then about what our design solution is, and then of course that's going to have to be constructed. So thanks for watching this one, and I hope you learned something. First, we're going to talk about how we built this particular home. So what we did is we dug the hole for the foundation just like normal. In our area, we've got a pretty shallow frost depth. Crawl spaces are very, very typical. So we built the foundation, footing, stem wall, very conventional. And then we also put in a footing drain. What a footing drain is it's a drain that goes up against the foundation in order to catch, the way we view it, or the way I view it, is as to catch groundwater. So it's a pipe. There's drain rock involved, there's filter fabric that goes over it, and that pipe has little holes in it. Those holes are called perforations. So if water is below the surface, we'd call that surface water. So if it's subterranean water, if the water table comes up high, it'll seep into those holes, and then it'll have an easy path to leave that system. So we have a footing drain in there. We also have downspout drainage, which is piped separate from the footing drainage. So this is a hard pipe with no perforations, and it has little receivers, if you will, or stub-ups in order to receive the downspouts. The downspouts receive water from the gutters, and the gutters receive water from the roof. So we're catching groundwater, was the hope. We would be receiving rainwater from that building footprint where the roof footprint is. And then the other thing we did is we sloped the grade away from the house. And so you're catching the surface water on the site that way. You're using gravity with every one of these systems. So there's nothing mechanical involved in order to catch rainwater and to catch groundwater if there is any. And then something else we installed at the toe of the hill, which was in the back of the house, a French drain. You might hear them call curtain drains. So we've had that positive slope coming away from the house, but then we also had a hill in the back. And so we put a perforated pipe in there with a lot of gravel, filter fabric, and again, we were trying to catch that water. Now that's all liquid water. Now let's talk for a second about latent heat or humidity. What is latent heat or humidity? Well, put simply, it's water vapor that's been in the air. We know from basic science class, you've got typically ice, you have liquid water, and you have water vapor, to keep it very simple. Each one of those you can look at is having a certain amount of energy associated with it. The less energy that water has, the more it's going to be a solid. There's not very much activity going on there. As BTUs get put into the ice, it starts to change phase. It starts to melt. It starts to become liquid water. So everything that we talked about so far was handling liquid water. And in our climate, we're in the Pacific Northwest, that's really the key. You have to think about liquid water or you're going to have problems. But as you put more energy into that liquid water, it will phase change again and become water vapor, or it will become humidity. It'll become water that's in the air. So when we think about that, if you watch the video that I did on how a match works, touched on BTUs, there are more BTUs in water vapor than liquid water than ice. As we add that thermal energy, it changes phase. So how did we account for liquid water, or for water vapor rather? Well, we put down a vapor retarder. And that vapor retarder is to keep any gap when water becomes, I'll use the word vaporized, from the ground, from getting through that plastic barrier through diffusion. Going through that plastic barrier, and then all of a sudden you have water vapor in the crawl space. So in the way it's supposed to work is that vapor retarder, that vapor barrier would prevent water from coming up. So far so good. Now I'm going to talk to you a little bit about the floor system, how we built the actual wood part of the structure. So the floor joists typically are built on top of a foundation, or you can recess those down inside the foundation using hangers. That's what we opted to do because we wanted to lower the elevation for a homeowner to be able to walk into the house essentially without a threshold. What that ends up meaning is we had to get more creative with our vents because it is a vented crawl space. There's not as many as you would ordinarily see in the Pacific Northwest, but we did still have venting. Because there's not as much latent heat or humidity outside, our crawl spaces stay pretty temperate, and there is a code requirement in our area that if you seal up a foundation, you have to do radon mitigation. Now, I don't even remember when we initially did this, if I knew about the radon side of things, but just passing that along to you at this point, we actually don't live in a high radon area, but it's part of the building code, so it is what it is. If you decide to close off a foundation, you really need to understand what's happening as far as radon is concerned and whether or not you need to mitigate it. In fact, I would require, or I would suggest that you would test for radon at the individual structure if you're thinking of doing a conversion from a vented crawl space to an unvented, just to make sure that your site-specific situation is thought through and is cared for. So far so good. Now I'll talk to you about what ended up happening. Before the house was sold, we found water in the crawl space. It didn't make a whole lot of sense as to what was going on. I couldn't wrap my brain around it. But what we ended up doing is hauling in bucket after bucket after bucket of pea stone, very small gravel, and that would serve as a capillary break. Water wouldn't tend to be able to, through capillary action, move up like it does with soil. And so we put that in, then we reinstalled the vapor barrier, we taped the seams, we thought we were good. Unfortunately, after we sold the house, we discovered that there was still a problem. So now let's talk about that. While we thought that we had it licked, unfortunately there was so much water later on in the crawl space that vapor retarder, it acted almost like a waterbed, if you've ever seen a waterbed or have touched it. So I'll probably show a clip for us pumping the water out. Thankfully we have a very heavy duty pump, and so we ended up pumping the water out of the crawl space. So that was the situation. We thought we had taken care of the roof water. We thought we had taken care of the water table. We thought we took care of capillary action. We thought we took care of vapor. But there were some holes in that vapor retarder, and it's hard to get that dialed in perfectly. So now we had to go to the next step. Now I'll take you through that process. In this video you can see we essentially have a pump chamber. There's little perforations at the bottom of that little 5-gallon bucket. It's allowing water to get drawn in, and then the sump is pulling the water up through the big hose and out onto the street, which we'll see in just a moment. Lots of water during this particular event, that is for sure. Now this is out on the driveway. This was just to get the water out of the crawl space. It ran for hours, literally. Lots of gallons. So now it comes down to redesigning and trying to fix this situation. What I personally subscribe to is making sure that you get permits and that you know the code to a reasonable degree. The fact is, not every builder is going to know the code as well as maybe an architect would, but we do a lot of our own work, a lot of our own thinking, and so I do try to be code compliant. So I called up the local jurisdiction, and maybe I actually went down there first. That's what I did. I went down to the building department and I wanted to find out. We were thinking of putting in a sump and possibly a dehumidifier. Would we need to get permits for that? Additionally, because we had decided that the only real solution here was to do a sump, where we would discharge that water to. Where would we discharge the condensation from the dehumidifier? What about the electrical side of things? If you're using mechanical ventilation or mechanical equipment now, when does that get kicked in as far as getting permits there? So I went down to the local jurisdiction to try to find out, and the lady didn't know whether or not off the top of her head I would need to get permitted for that mechanical equipment. So she directed me to the head of the department. So I called her, explained the situation, leaving it in a voicemail, and then she called back. And when she called back, it was kind of interesting. She was kind of perplexed, like, you're actually asking for something? She's new in this particular department. I don't know if she's been responsible like this before, but just think about the impact it can have. I don't want to digress too far, but the good reputation we can get by actually asking questions. At first, she didn't think that we would need to get a permit, but as we talked through it more and more, she felt that it would be wise, and I totally agree. Now, whatever equipment we get put in there will be inspected. The city will know what happened. The homeowner knows I wasn't trying to skirt corners. So if they ever sell the house in the future, everything is above board. So in talking with her, I wanted to find out, because of what the company who's going to do the installation had brought up, whether or not we could discharge the sump into the sanitary sewer. Now, I didn't think we were going to be able to. But part of due diligence is asking those questions, even if we don't think it's necessary to ask those questions. So, as it turns out, this is a force main type situation. I already know by talking to Public Works before that the system in this area has some struggles, shall we say. I'll keep it at that. So no, we need to discharge it to the surface. In the midst of this conversation, a theory that I had is relatively answered. Nothing made sense for where this water was coming from, except possibly from the municipal side of the equation. And our official offhandedly commented that they are having some issues. I don't want to get too detailed, but it does make sense that we pretty much did our job. But if the location that you're discharging to is having any kind of a situation, it makes sense. So again, I don't want to get too far into those details, but just letting you know, pretty well have a smoking gun there. I don't want to put a check valve where our drainage goes to, because then it causes a maintenance situation. We'll have to tear up the yard, have to redo the landscaping. I just don't like that solution. And what if I'm wrong? Without doing testing, my theory might be wrong, that the water table is rising due to no fault of my own. I'm not willing to take that risk. So I would rather do something that is tested, that is tried, and that is true. And so our solution is going to be to install a sump, and we're going to install a dehumidifier. Now let me explain to you a little bit about a sump. What is a sump? A sump is a submersible pump. So while this whole system has been using gravity in order to drain, Now we need to get electricity involved. So houses run on AC power. There's an AC sump or a submersible pump put into a chamber. That chamber can collect water, and as that water level rises, it will activate that sump. I think there's a float with this one. I'm pretty sure it's a float, but in any case, it triggers once that water level activates the pump, and as the water level lowers, the float or whatever the device is will raise, thereby disengaging the pump. So as the water level comes up, now it'll activate and it'll work that way. The nice thing about the system that we're going to be using is it has a backup sump. So what happens if you lose power? Because the fact of the matter is, when we get a heavy rain event, it might be accompanied by wind. And so if you lose power and now you're using electricity to solve the problem, you have to make sure that you have a source of electricity. So I'm going to go out and buy, it's a marine battery from O'Reilly's Auto Parts. I have to make sure that it meets the spec for this whole sump system. It has to have 105 amp hours. I'm telling you what, this is a pretty heavy duty battery. The system we're using is very robust, it's very strong. When they're testing them, it's my understanding that it's more for continual use for how long the pump lasts, but in practice that's not really what happens. As the water level goes up and it lowers, the electricity, whether it's being called for from the line voltage through the house for the primary pump, or through the DC voltage from the marine battery, it will work intermittently. So our events don't last too terribly long. The capacity of this pump will be able to lower the water as needed, and that will take care of that. But that brings us to the other side of the equation. What about the latent heat? What about the humidity? We'll talk about that next. So if you remember what we talked about earlier, water changes phase depending on how much energy is applied to it. So if there's water that's getting into the crawl space, eventually it's going to dry. It will either drain, soak into the soil, or it'll evaporate, thereby leading to an elevated moisture level in the crawl space. Is it really an issue? I don't know the answer to that. But what I do know is I'm a home builder who wants to have a happy customer, and I'm a home builder who likes to get to sleep at night. So in this case, we're in it this far. While I'm ordinarily not a belt and suspenders type of mentality, in this case, I think it makes sense. So even in the summertime, I commented, I think earlier, that we do get more latent heat, more humidity in the summertime. I think it's just wise for us to make sure that we're not going to have a moisture problem. So we're going to install an April Air dehumidifier. And in the future, I'm going to do at least one video digging into that particular piece of equipment. But what this will do is it samples the air periodically, and when the setting gets reached, or I don't want to use the word satisfied, it will pass air over it, over the coil, I think is what it is. Anyway, you'll have to watch a future video. It'll get that air cold. That water, now that it's losing its energy, will condense into liquid water. That liquid water will go through a drain via gravity into the sump. So we do have some electricity feeding the equipment. I still like to use gravity when I can. Gravity is a nice constant. As far as I know on this planet, we've never not had gravity. So that will keep the humidity down, not only if there's any, let's just say there's water that happens to pass through the foundation walls through diffusion, and then all of a sudden it evaporates into the air. I just think it's a smart play for us to handle it this way. So I mentioned electricity. Now let's talk about that side of the equation. So I sent the specifications for the sump system and the dehumidifier over to our electrician I'm not as well versed in electrical requirements when it comes to getting a permit. In this case, we need to get a permit. I think we're going to have 2 new dedicated circuits. Those are going to have to run through the garage via surface mount conduit. As I mentioned before, the floor system is recessed down, so it's a little bit more difficult to get in there. I think we'll actually have to punch through the kitchen into the back of a cabinet and then bring it down. It'll all be very clean. It won't really affect too much, but there's a lot of little pieces to get in there. What we'll be doing though is taking electricity from the local service provider, the electrical provider, and taking that, converting the electricity into mechanical energy in order for the pump to work. We'll be using electricity in order for the dehumidifier to work. And then, to be honest, I haven't fully figured out the control side of this equation yet. I'm still working through it, but that will take care of this situation once all is said and done. There is one last thing that I wanted to talk about when it comes to this, and that's a Washington amendment to the local building code. If you do sealed crawl spaces, again, remember, you may have to take care of the radon side of things. But there's also the bulk water side that we have to think about and the vapor side. So there's various ways that this can be done, but in Washington State there was a recent amendment that you can actually use a dehumidifier when it comes to conditioning a crawl space. So there's ways you can allow air to pass between the upper and the lower. I think you can do exhaust only, which would depressurize, possibly even drawing air down from the building. So one of the other reasons I'm doing this is to gain experience. I'm using an April Air dehumidifier, and we've never actually used a dedicated dehumidifier on a project before. So when possible, I do like to experiment, experience something, because in the future, maybe we decide to go ahead and do conditioned or sealed crawl spaces. This might be the smartest way to do it. I just don't have the experience because there's always things we learn. I've spent a lot of time reading through specs, understanding how this is all going to work, but there truly is no substitute for experience. So that is another side of this, is knowing what our local building code requires. So for future projects, I'll be able to build with experience. Well, I hope you've enjoyed this video. I know it was me pretty much just sitting here talking to the camera, hopefully talking to you, the viewer, and I really do hope you learned something. We thought we did everything right. We even thought we fixed it and took care of it. But the water's coming from somewhere, so that's kind of a given. Do we know precisely where the water's coming from? I feel pretty solid in what I think it is, but I do feel confident about what our solution is. We will be able to get rid of the water and we'll be able to dehumidify. Whether the dehumidification will take place because of that groundwater or because of just higher humidity levels, it will be a good move if either of those things trigger the dehumidifier. The homeowner's going to be happy, and I'm going to be happy as the builder. So again, I'm Brian with Pioneer Builders. This channel is devoted to all things design, construction, operations, maintenance, and yes, in this case, repair to a pretty newly built home. Thanks for watching, and I hope you learned something.